Assalamualaikum warahmatullahi wabarakatuh. My name is Arif Putra Ardiansyah for Diploma Safety Engineering in Shipbuilding Institute of Polytechnic, Surabaya. I will presentation about the results of my final project. My final project is fire risk assessment and evaluation of fire protection system design in tire retail company warehouse. The purpose of my final project is first identifying hazards in retail company warehouse areas using the HIRADC, hazard identification and risk assessment determining control method. The second, analyzing fire risk with fire risk assessment using the fire safety conceptuary method in retail company warehouse. And the last, provide recommendations for designing the installation of an active fire protection system that complies with NFPA 230 along with validation using PipeFlow Expert software from the design carry out. This is a result of fire identification source danger in the warehouse. First, in the process loading and unloading with activities arrangement of items in the warehouse. In there has a source of dangers that is physical and then chemical and then psychosocial. About physical, the source of danger is first new tires, used tires, new oil, and used oil that are unloaded or loaded and arranged in the warehouse range. The second, new tires, new oil, used oil that are close together in one area. The third, storage of wooden pallets in the warehouse. About chemical, first, there's oil in the warehouse area from used oil and a leak in the defect in the new oil packaging spillage. The second, there's a gasoline spill on the leaking forklift fuel used during loading and unloading. About psychosocial, the source of danger is first, concentration of workers insufficient. The second, lack of understanding of equipment operation. And the last, workers' ignorance of existing regulations. Second, in the process maintenance with activities welding iron plates and cutting iron plates using grinders, in there has a source of dangers. That is physical and psychosocial. About physical, the source of danger is the activity is carried out in a warehouse that cause parts. About psychosocial, the source of danger is first, concentration of workers. The second, lack of understanding of the operation. The third, lack of knowledge about fire hazards. In the risk assessment or risk matrix is used category with 4 levels, namely extreme risk, and then high risk, and then moderate risk, and low risk. We're in obtaining this value by distributing questionnaire to 7 warehouse employees, including the expert judgment. Based on the results of the questionnaire, the risk assessment obtained for the loading or unloading process is 12. That's classified as extreme risk. While for the maintenance process, the risk assessment obtained is 6. That's classified as moderate risk. In this case, recommendation control given is on the loading and unloading process. First, routine checks of forklifts that are used operationally and are serviced regularly. The second, updating work procedure operational standard in the warehouse about arrangement of combustible goods in the warehouse and sorting defective items. The third, reinforcing punishment on agreed procedure operational standard violators. And then upgrading knowledge about occupational health and safety by management. And the last, adding adequate active fire protection about upper and hydrant installation. In the maintenance process, the recommendation is first, moving, welding, and grinding work not in the warehouse. The second, providing knowledge 1 time a week regarding occupational safety and health, especially fires. And the last, completing personal protective equipment in the form of safety gloves, safety shield, and safety jacket, so that the existing risk value for the loading and unloading process drops to 4 and is classified as low risk. Then in the maintenance process, it drops to 1 and is classified as low risk. And the next step is analysis of fire risk. The risk assessment and evaluation of fire hazard from the identification results are carried out using the fire safety concept tree based on NFPA 550. At NFPA 550, the assessment is divided into 4 categories, which are first, non-existent, the second, below standard, and then above standard. This is the results of fire assessment by using fire concept tree method. In the risk of fire risk, there are 2 things to note. At first, prevent fire ignition. The second, manage fire impact. That's the fire risk about prevent fire ignition. I will try to explain. From the assessment carried out, it's known that the purpose of fire safety in the warehouse can be met on the prevent fire ignition criteria, because it has a standard value. This value is obtained from the lowest element in the gate or branch. Even so, some elements still were non-existent. That's the risk of fire risk about manage fire impact. I will try to explain. In the manage fire impact category, the goal of fire safety has not been achieved because the assessment carried out is still rated below standard, meaning that the management of the fire impact in the warehouse areas is still below standard because managed fire impact has a gate or branch. So the assessment is obtained from the top value on the element below it, namely the control combustion process element with a value of below standard. About control addition for fire safety concept tree in category prevent fire ignition. With the addition of control, making a change in the value of some of the lowest elements or on the elements above it. With the change in the value of each element, the value of each category is in prevent fire ignition and manage fire impact. First, that's the control addition in prevent fire ignition. I will try to explain. The control addition in prevent fire ignition is first, relocation of welding and cutting place not in warehouse. The second, addition of liquid soap during cleaning on forklift lines. The third, storage of new defective oil fluid not in warehouse. And then, performing regular maintenance on forklifts. And the last, regular inspection of fuel tank on forklift. Second, that's the control addition in managed fire impact. I will try to explain. The control addition in managed fire impact is first, installation of firearm system on control combustion process, precisely on control fuel element with communicate signal sub element. The second, relocation of welding and cutting place not in warehouse, and then adding active fire protection in the form of hydrant in extinguishing fires. And the last, fire barrier wall installation in the warehouse area. So after being given control recommendation on prevent fire ignition, each category and each element get the standard value. Is in accordance with NFPA 230. Will in manage fire impact from the beginning, the fire risk assessment is still below standard. After being given some control, the fire risk value becomes standard and also in accordance with NFPA 230. And the next step, I will explain about evaluation fire protection system in the warehouse. First, I will explain about fire extinguisher. With the data obtained in the form of a general design warehouse area for a tire rental company, the number of fire extinguisher or APR needs in the warehouse. In the warehouse area will be known based on NFPA 230. The determination and number of light fire extinguisher refers to NFPA 10 of 2018 concerning the standard for portable extinguisher. From the table, it can be explained that the fire hazard category in the warehouse is an ordinary hazard category with a fire class classification, namely Class A and Class B, because the warehouse stores flammable objects such as wooden pallets, paper, cardboard, plastics, fabrics, tires, and store flammable and combustible liquids such as gasoline and oil. In this case, according to NFPA 10, The upper rating in the warehouse area is a 20B rating because in the provisions of the upper placement distance for class B, the maximum range of one upper is 50 feet or 15.25 meters, so that according to calculation, the total number of fire extinguisher upper needs in the warehouse area as many as 3 pieces, with a distance between fire extinguisher is 22 meters. This is fire extinguisher placement evaluation design with a distance between fire extinguisher that is 22 meters. Second, I will explain about hydrant installation system design. In this final project, the design of the hydrant system was determined based on NFPA 230 and NFPA 14. The number and placement of hydrant pillars or hose connection were determined based on NFPA 230, while the piping planning design was determined based on NFPA 14. And the next step about water capacity. NFPA 230 states that the hydrant must be accessible with a hose connection that has a diameter of 2.5 inches. With the provisions of the hose connection in NFPA 14, the standpipe provisions use are class 1. The water discharge required for a class 1 standpipe is 1,893 liters per minute, with a jet length of 30 minutes. So the minimum water volume for each hydrant pillar is 56,790 liters. To accumulate in cubic meter is 57 cubic meter. It is known that one hydrant pillar has a travel distance of 35 meters as required by NFPA 14. Then the calculation results show that the number of hydrant pillars needed in the warehouse with the protection of each pillar is 2 hydrant pillars. About total quantity of waters. The water requirement of the hydrant system can be calculated from the value of the volume of water for each hydrant multiplied by the number of hydrants that will be used in the event of a fire, so that the minimum water requirements needed in the warehouse area are 114 cubic meters with 2 pillars of hydrants. With this reservoir capacity, the size of the reservoirs that will be used to accommodate the volume of water needs for the hydrant system in the warehouse area is 6.5 meters long and then 6 meters wide and 3 meters high. This is isometric drawing of hydrant pipe system installation with main dimension of reservoir 6.5 meters long and then 6 meters wide and then 3 meters high. In isometric drawing of hydrant pipe system installation, is suction pipe with length of dimension is 6 meters, 6 inches diameters and 0.24 meter head loss. And then discharge pipe with length of dimension is 73.4 meters and then 6 inches diameters and 1.2 meter head loss. And then the last discharge pipe with length of dimension is 3.2 meters and then 4 inches diameters and 0.8917 meters head loss. Then the total head loss in the hydrant piping installation system is 2.356 meters. In calculating the pump power that must be calculated is the static heat and pump heat. In the calculation, the static heat is 0.3 meter and the pump heat is 73.43 meters. So the pump power in the hydrant installation system is 3.094 horsepower. The type of pump used to drive fluid in the hydrant system in the warehouse area is Ebara MD 50 125 or 3.0 with maximum power is 3 kilowatt or 4 horsepower, and then max pressure is 10 bar, and then max liquid temperature is 110 Celsius. The simulation of the piping system planning for the furthest hydrant in the warehouse area shows the results of the design modeling as shown in the figures. This is a pipe flow expert simulation. The result of pipe flow expert simulation is the value of the heat pump simulation result has a difference with the calculated value. Based on manual calculation, the value of the heat pump is 73.43 meter, but in the simulation the value of the heat pump is 78.085 meter. It shows that the results of manual calculations are smaller than the simulation results. There's a difference between manual calculation and simulation because the reference used in the calculation in the study is different between manual and software calculation. The calculation of percentage error. From the calculation below show the percentage of error in the value of 4.65%, means that the statistical measurement of the accuracy of forecasts are included in the estimate value prediction is very good because the percentage error in the count has a value below 10%. And the last conclusion. The conclusion is my final project is first, the results of hazard identification using the HIRADC, hazard identification and risk assessment determined control technique in the warehouse area have a hazard risk level with the categories of extreme risk and moderate risk. Then after the additional of hazard control, the level hazard risk in the warehouse area drops to low risk. The second, the results of the fire risk analysis using fire risk assessment with the fire safety concept 3 method in the warehouse area are classified in the below standard and non-existent categories. After adding control recommendations, the fire risk category in the warehouse area increased to standard. And the last, the results of the evaluation and recommendations for the fire protection system in the warehouse are as follows. A. The number of needs for light fire extinguishers in the warehouse area are 3 pieces with a 20B rating of the multi-purpose dry chemical fire extinguisher with a distance between light fire extinguisher of 22 meters. And B. The number of hydrant pillars need in the warehouse area is 2 pieces with simulation results using pipe flow expert software. The pump heat value is 78.085 meter, while the calculation is done manually. The pump heat value of 73443 meter, so that the percentage of error obtained is 4.65%. And then recommendation in my final project is first to be able to be applied to the company. It can carry out the preparation of a budget plan in the provision and installation of active fire protection in the form of a light fire extinguishers and the installation of hydrant. And the last, my recommendation is use other software such as WaterCat software, which can be used for comparison percentage. That's my explain about my final project. Thanks for your attention. Assalamualaikum warahmatullahi wabarakatuh.